Did you know that one of the hardest places to build on Earth is home to the tallest bridge in the world? It's the Huajiang Bridge in Guizhou, China. This massive structure stretches nearly 3 kilometers long, suspended 625 meters above the ground, spanning the sheer cliffs of Guizhou province, where more than 90% of the land is made up of mountains and plateaus. In the past, drivers needed about 70 minutes to cross this canyon, navigating winding and dangerous mountain roads. Today, the journey takes only about 1 minute. So how were engineers able to build a gigantic bridge between two cliffs that were almost impossible to access? Today, join Terran Works as we explore the engineering story behind one of the most daring bridges ever built on Earth. To understand why the Huajiang Bridge became one of the boldest engineering projects in the world, we first need to look at where it was built. Guizhou Province lies in southwestern China, a region famous for its towering limestone mountains and canyon systems so deep that many areas are nearly impossible to access. According to geographic statistics, more than 92% of Guizhou's land area consists of mountains and plateaus, making the construction of transportation infrastructure a challenge that has persisted for centuries. The roads here often wind along steep cliff faces. In many sections, the roadway is only wide enough for two vehicles to squeeze past each other, while on the other side lies a drop of hundreds of meters. In the past, many villages in Guizhou were almost completely isolated. People had to walk for hours along narrow mountain trails or cross valleys on makeshift rope bridges, some of which were built as far back as the 19th century. The complex terrain also brings extreme weather. Powerful winds can rush through the narrow valleys at speeds of up to 30 meters per second, while rock falls and flash floods occur frequently. From a geographical perspective, Guizhou resembles a maze of rocky mountains. But from an economic perspective, it sits along one of China's major transportation corridors, the G56 Hangzhou-Rili Expressway. This highway stretches thousands of kilometers, linking major economic centers in eastern China with the border regions near Myanmar and Southeast Asia. However, along this route lies a massive natural obstacle, the Bayan River Canyon. Before the bridge was built, crossing this canyon meant a winding 70-minute journey along dangerous mountain roads, making the transportation of goods slow and costly. For China's infrastructure planners, this was a major bottleneck. Without a solution, the entire expressway running through the southwest would be interrupted by a mountain road section only a few dozen kilometers long. The idea of building the Huajiang Bridge was therefore born with a very clear goal: to shorten the journey from more than an hour to just about 1 minute. This would not only speed up transportation, but also open new economic opportunities for regions that had long been isolated. The Huajiang Bridge is not just a bridge, it is an engineering record. The structure stretches 2,890 meters in total length, with a main span of 1,420 meters, longer than the Humber Bridge in the United Kingdom, which once held the record for the world's longest suspension bridge for 17 years. But what truly makes this project astonishing is not only its length, but its extraordinary height. The bridge deck sits 625 meters above the canyon floor, making Huajiang the tallest bridge on the planet. To put that into perspective, if the Eiffel Tower were placed beneath this bridge, its top would still be nearly 300 meters below the deck. The entire structure of the bridge uses about 49,000 tons of steel, roughly equivalent to the weight of nearly 7 Eiffel Towers. The steel girders that form the bridge deck alone weigh more than 21,000 tons, creating a colossal structure suspended high in the air. The two massive bridge towers rising from the cliffs are also remarkable engineering feats. The North Tower stands 262 meters tall, while the South Tower reaches 205 meters. These towers support the enormous suspension cable system that carries the load of the bridge deck, holding it suspended high above the deep canyon below. When people hear about a bridge nearly 3 kilometers long, many immediately ask, why not build a conventional bridge with multiple concrete pillars in the middle? The answer lies in the terrain the bridge crosses. Huajiang Canyon is simply too deep, too wide, and too extreme to support any mid-span pillars. With a main span of 1,420 meters, choosing a traditional girder bridge or arch bridge design would require a massive system of intermediate supports. But here, those pillars would have to stand in the middle of a canyon more than 600 meters deep on fractured rock formations above fast-moving water, while rock falls and powerful winds regularly sweep through the valley like a natural wind tunnel. Even transporting construction equipment down to the canyon floor to build the foundations would have been an enormous logistical operation. On top of that, such work could destabilize the geology and disrupt the delicate ecosystem of the entire valley. For these reasons, engineers chose a suspension bridge, almost the only structural design capable of spanning such a vast distance without intermediate supports. Instead of being supported from below, the bridge deck is suspended by a system of massive steel cables, transferring the entire load to two towers and to anchor blocks embedded deep within the cliffs at both ends of the canyon. But deciding to build a suspension bridge was only the first step. Before a single steel beam could be lifted into the canyon, engineers had to answer a critical question. Was the rock beneath these cliffs strong enough to support a structure weighing tens of thousands of tons? To find the answer, geological survey teams drilled deep into the weathered limestone layers of Huajiang Canyon. Drill bits stretching dozens of meters penetrated fractured rock formations to extract core samples. Each sample was then sent to laboratories, where engineers analyzed its compressive strength, stability, and resistance to vibration. Once all the data had been collected, the design team began building a complete digital model of the bridge. Within this model, they simulated thousands of different scenarios, from powerful storms and seasonal temperature changes to major earthquake events. After months of simulations, the result was a suspension bridge design capable of withstanding winds stronger than 200 kilometers per hour, while maintaining structural stability throughout a design lifespan of more than 100 years. With the final design approved, the project moved into its most challenging phase, constructing the massive bridge towers. In any suspension bridge, the towers are the backbone of the entire structure. The weight of the bridge deck, the suspension cables, and the traffic that travels across it ultimately transfers its forces into these two massive structures. At Huajiang, constructing the towers began with a particularly difficult task: building foundations directly into the cliffside rock. Engineers had to drill deep into the bedrock to create a system of large-diameter foundation piles. These piles were reinforced with high-strength steel and earthquake-resistant concrete. Drilling in fractured rock formations with underground water made this stage extremely complex. Even a small error could weaken the entire foundation. Once the foundations were completed, the towers began rising level by level using a self-climbing formwork system. This system allowed concrete sections to be poured continuously, while the formwork slowly lifted itself higher as the structure grew. The process lasted many months, until the North Tower reached 262 meters in height and the South Tower rose to 205 meters. From the floor of the canyon, the two towers look like giant pillars rising straight into the sky. But they were only the beginning, because their real purpose is to hold the enormous suspension cable system that would soon be stretched across the canyon. After the two bridge towers were completed, the most spectacular phase of the entire project truly began: installing the main suspension cable system across Huajiang Canyon. Each of the bridge's main cables is not a single steel strand. Instead, it is made from thousands of high-strength steel wires, each only a few millimeters in diameter. These wires are stretched in parallel, tightly bundled into a massive cable, then compressed and coated with protective layers to prevent corrosion. The two main cable bundles curve over the tops of the towers and extend toward both sides of the canyon, where they are anchored into huge concrete anchor blocks embedded deep within the mountain rock. This system acts as the spine of the bridge, receiving the loads from the bridge deck and transferring the forces to the towers and the anchors at both ends. Once the main suspension cables were fully installed, engineers moved on to the next phase, hanging the steel segments that form the bridge deck. In total, the bridge consists of 93 steel girder sections, each about 25 to 30 meters long and weighing between 200 and more than 300 tons. These enormous components were transported using a cable crane system, a type of crane that runs along cables stretched across the canyon more than 600 meters above the ground. The steel girders were suspended in mid-air before being carefully lowered into place with an accuracy of just a few millimeters. Installation progressed simultaneously from both sides of the canyon, with each segment moving gradually toward the center until the two halves finally met. The moment when the two sides of the bridge were joined together became one of the most memorable milestones of the entire project. After the main cable bundles and the massive steel girder sections were fully installed, the bridge moved into another critical phase, applying protective coatings to the entire structure. At an altitude of more than 600 meters above Huajiang Canyon, strong winds, rain, and constant temperature changes could cause the steel to deteriorate quickly if it were not properly protected. Workers operated on mobile suspended platforms along the towers and steel girders, using brushes, rollers, and handheld spray equipment to apply layers of paint across the structure. The process involves several layers, starting with anti-corrosion primers and ending with the outer protective coating. The bridge's distinctive blue color is not only aesthetic, it also helps shield the steel from corrosion and environmental damage. Once the final coat was completed, the bridge was almost ready for the next step: load testing before opening to traffic. In the world of bridge engineering, a bridge is only truly considered complete once it has passed strict load testing. For the Huajiang Bridge, engineers conducted these tests by placing dozens of heavy trucks, each weighing between 30 and 40 tons, onto the bridge deck. The vehicles were positioned at different points along the 1,420-meter main span to simulate real traffic situations, such as multiple trucks moving simultaneously or heavy loads concentrated in a specific area. Throughout the testing process, more than 200 sensors installed across the bridge structure continuously measured critical parameters, including deck deflection, steel girder vibrations, and deformation of the suspension cable system. All of this data was transmitted directly to a control center, where engineers analyzed it in real time. If every measurement remained within the permitted design limits, the bridge would be certified as meeting safety standards. These tests typically last several weeks and may even be repeated under different conditions to ensure absolute accuracy. Only after the entire testing process is completed and all technical standards are satisfied can the bridge officially open to traffic. After its inauguration on September 28, 2025, the Huajiang Bridge not only became the tallest bridge in the world, but also quickly emerged as a new symbol of connectivity in southwestern China. The biggest change lies in travel time. In the past, vehicles needed about 70 minutes to cross Huajiang Canyon, navigating winding and dangerous mountain roads. Today, that journey takes only about 1 minute, as vehicles drive straight across the 2,890-meter bridge, greatly improving connections between cities such as Guiyang, Anshan, and Qianshinan along the G56 Hangzhou-Rili Expressway. The bridge also opens up major opportunities for tourism. Guizhou is already known for its spectacular landscapes, including the dramatic Huanggoshu waterfall, more than 100 meters wide, and the scenic Guanling National Geopark. With the new bridge in place, the region is expected to attract millions of visitors each year. Perhaps most interestingly, the bridge itself has become a tourist attraction. At the top of one of the towers, rising more than 260 meters high, a cafe and observation deck allow visitors to admire the entire canyon from an elevation approaching 700 meters. As a result, Huajiang Bridge is not only a vital transportation route, but also a new tourism icon of Guizhou. From the rugged cliffs of Guizhou to the massive suspension cables hanging high in the sky, the Huajiang Bridge shows how modern engineering can transform places once considered impossible to build into vital transportation routes. The bridge does more than shorten a journey across a canyon. It is changing the way an entire region connects with the world. What do you think about this incredible structure? If you had the chance, would you dare to drive across a suspension bridge more than 600 meters above a canyon? Leave your thoughts in the comments below, and don't forget to subscribe to the channel so you won't miss the next engineering journeys with Terran Works.